On a hot summer day, a maple tree 15 meters tall loses up to 220 liters of water per hour to the atmosphere by evaporation from the leaves. To prevent wilting, the same amount of water has to be transported from the roots to the leaves of the tree every hour. How is that accomplished? There are several processes that contribute to the transport of water up the tree. We will be focusing on the most significant one, transpiration pull. Here, we see the cross-section of a leaf with little blue dots representing the water molecules. The concentration of water vapor in the atmosphere is lower than that in the intercellular spaces of the leaf. As a result, water vapor diffuses from the intercellular spaces through the stomata and into the atmosphere through transpiration. Let's take a look at what goes on at the surface of a mesophyll cell. Within the leaf, water evaporates from the thin film of moisture surrounding the mesophyll cells and enters the intercellular spaces. As water evaporates from the aqueous film, this increases the curvature of the water surface and thus increases the surface tension of the water film. Water then moves from the mesophyll cells into the water film in order to reduce the surface tension. This, in turn, causes water from the xylem to be pulled into the surrounding cells and air spaces to replace the water that was lost. As water is removed from the leaves through transpiration, this generates a water potential gradient from the roots to the leaves. The resultant force that draws water up the xylem is known as transpiration pull. Also contributing to the ascent of the xylem sap is the cohesive forces between water molecules. This allows for a continuous thread of water to be pulled up the entire length of the xylem.